A particle moves in a circular path under a central fictitious force. F is proportional to 1 upon r cube. The time period is. Okay. So we've been given that F is proportional to 1 upon r cube, which is F is equal to K into 1 by r cube, replacing this proportionality with the proportionality constant K. Now, we know that when this is taking place in a circular path, the central fictitious force will provide the necessary centripetal force for circular motion. Or in other words, this fictitious force F can be written as the source of the centripetal force F centripetal, which actually is mass into centripetal acceleration. Let us quickly recap what this actually means. So we know that when any object executes circular motion, right? When any object executes circular motion, either clockwise or anti-clockwise, the object will experience a centripetal force which will be acting radially inwards towards the center, right? In fact, it is this centripetal force which sustains the circular motion. Now, what is the centripetal force? Well, in its practical terms, there is no force that is actually centripetal in nature. There are other forces which act as the centripetal force. Say, for example, when the sun revolves around the earth, the gravitational force between sun and earth, which is the gravitational force F gravity, it acts as the centripetal force, right? When a moving car, when a car takes around, when a car is going round and round around a circular track, it is the friction between, excuse me, it is the friction between the tire and the road that acts as the centripetal force. Okay. The force of attraction between the nucleus and the electrons is what is responsible for the circular motion of electron around the nucleus. The Coulomb force, the static Coulomb force, which acts as centripetal force there. Now, when this circular motion takes place while, say for example, if this is us holding a string, right? Holding a string here, and we tie a stone to this, and then when we rotate this, it is the tension along the string, the force of tension that acts as the centripetal force here. All right. So one such force here, that's something we don't know, we're not aware of, a hypothetical force or a fictitious force here, that is given to be as the mathematical form as F is equal to K upon R cube. And then we've been asked to find out the value of time period. So we know that when F centripetal is equal to m times the centripetal acceleration, which is v squared by r, F centripetal is mv squared by r. And in this question, the centripetal force is replaced by the, the fictitious force is acting as the centripetal force, which is k by r cube acting as mv squared by r. So r cube by r is r square. Everything else remains as it is. K here is a constant. M here is a constant. So what I can do is I can pull K and M to one side. Therefore, K by M, a constant by a constant, becomes another constant, that is gamma, say for instance. So we have gamma into 1 by r square is equal to v square. If I take square root on both sides, this becomes square root of gamma, which is a constant again, is equal to 1 by r into 1 by r is equal to v, right? So root of gamma, say some constant, say alpha. Okay. Now, what have we been asked to find out? Time period. What is time period? 2 pi r by v. What is v? 1 by r. I'm just discarding the alpha here for a while. So this becomes 2 pi r into 1 by r. Sorry, 2 pi r by 1 by r, which is 2 pi r into r by 1, which is 2 pi r square, and therefore this becomes 2 t is proportional to r square. Well, actually, yes, if you were to write this in a better way, this should be times alpha, alpha times 1. Now 2 pi by alpha is a constant here, right? So this becomes t is equal to another constant, say t is equal to constant a times r square. Now if t is equal to a times r square, it means that t is proportional to r square, which gives us the answer as option C. Okay, so yes, maybe you can make a note of this. Yes, I would actually suggest you make it. You know why? It's been a while that we discussed circular motion, and the concepts might fade away. Well, the concepts actually never fade away, but the theory portions might fade away from you. So making a rough note would help you to recall them better. All right. Okay, now we have a very interesting question that's based on, that is actually given on Kepler's law, although it is based on conservation of angular momentum.